So actually the behavior of capacitor and inductor, that the component is a storage. So actually when you switch on, it start to ramp up, and when you switch off, start to ramp down. But at this situation, we consider at CCM, continuous current mode, means that the current always fly or conducts on the positive. They are not going to the negative. They are not going to the negative, or they are not operating at border, what so called a border, they call boundary mode or discontinuous mode. But at this time we consider as continuous current mode or continuous conduction mode. Okay, it happens that when it start to ramp up, and when it went down, it will go down to the same level at where it starts. And when it ramp up again, and we go down to the same level at where it starts. So we consider, or we assume that the component is ideal such that it will behave like this. Okay, means that if you shift your duty cycle here, so now you assume at dt, or maybe this one is 0.8, let's say 0.8 of duty cycle, 0.8 of total time. Maybe if you shift down to here, maybe 0.2 or 0.3 duty cycle, you can see that the pattern or the graph will be almost the same. So it ramp up here, but it ramp down slowly down to here. And same if you shift your duty cycle to higher, means that instead of 0.8, maybe 0.9. So you can see that the curve will ramp up slowly but ramp down very sharp. Means that it start at certain level, it will stop at the same level per watt or where it starts at. Okay, this is the behavior of your ideal inductor. And the amount of how much actually the difference between minimum and maximum peak, minimum I min and I max in terms of your inductor current is referred as delta IL and delta IL. Okay, we shall see the equation of the formula of the equation in the coming discussion. Now we just try to understand how the circuits of on and off looks like, and how actually the curve or the behavior of the output voltage and current should be observed as. Okay, next we go to the IC. So from the equation just now, we can see that IC is equal to IL minus I out. IC equal to IL minus I out. Okay, so this is IC. So this is IR or I out. As we just been informed just now, I out is a stabilized or average output, because we already filter out the ripple. Okay, so assume that this is your I out. So this is your IL. IL minus I out. IL here minus I out. So means that you shall shift the whole pattern here down. So instead of it flies on the positive side, so means that your IC, the same pattern per your IL, but shifted the amount. Maybe let's say you have a 5 volt of your I out, so means that your IL minus 5 volt, so you shift 5 volt down. So this is your IC, same pattern per load inductor current, but shifted per minus the level of your I out or IR. Okay, this is your IC. Okay, and the ripple also should be the same, is that the amount of minimum value minus, or maximum value minus minimum value. So this is your delta IL, and same as delta IC. Okay. So per stated inside the book. So assumption that we made here is that the circuit is operating at steady state condition, and the inductor current is continuous, means that it will be always positive. And the capacitor, if you take a look at the capacitor should be considered as very large value, not so large but very sufficiently large, means that the output could be held constant. So the function of the capacitor is to maintain the output voltage level at your load. And the switching period considered as T, and the duty cycle assigned between 0 to T, and between 0 to full cycle of T. And all the components here are assumed as ideal, means that your current of your inductor and capacitor, where it starts, so it will return back to its normal position. Okay, during on state, we go to the formula or analysis in terms of their formula, what happened on each of the parts. Okay, during on state, okay, when we switch on here, so what happens that the switch conduct, and the inductor current and diode become reverse bias, and switch conduct, the diode, and become reverse bias. So this will result the positive inductor voltage. We have here VL equal to Vs minus V out. VL equal to Vs minus V out. So it causes a linear increase in inductor current. The current will increase gradually up to the duty cycle period. Then when you switch off, it will go down to the initial level. Okay. So Vs minus V out is equal to the amount of L times the rate of change of your current IL divided by the dt here. Is that the rate of current change divided by the duration of duty cycles. So the IL dt equal to the rate of current change divided by duty cycle, or delta T. And so the rate of change of your current is equal to Vs minus V naught, because VL is equal to this value, the amount of Vs minus V naught divided by L. So you can see that the rate or the rate of change in terms of current during close or during on switch is equal to Vs minus V naught divided by L times dt. So this is happen here. Means that the amount or the amount of this area, this is the delta I during on condition. So what happens during off, when the switch is open, means that off and open. This one is closed, means that when you close the switch. So this one during off. So VL equal to negative V naught. You can see just now VL equal to negative V naught equal to the amount of inductor value times the change of current divided by the change of time. So now this happened during this period. Just now on the on state, this one is happened on the off state. So the diode is forward biased to carry inductor current. So the I dt equal to negative V naught divided by L. So the dt now is 1 minus t. Just now dt is here. Now dt is 1 minus d, and 1 minus d times t. So equal to negative V naught divided by L. So during open means that during off state, the amount of your delta IL equal to negative V naught divided by L times the remaining time of 1 minus d times t. Okay, this is the two condition or formula which happen on the on state and the off state. So on state and off state. So these two values actually, you can see. Okay, as we mentioned just now, you start at certain level and it should stop at the same level. So means that by right your delta I L during on, when plus delta I L during off should be 0. And you plus IL on and IL off, the amount should be 0. So this value is equal to this value. So when you solve the equation, you will see that V0 divided by Vs equal to dt divided by T equal to D. Means that V0 equal to V0 divided by Vs equal to D. So or V out equal to D times Vs. So V0 equal to D times Vs. So means that we are able to program or obtain or determine how much V out that we required just by adjusting the duty cycle compared to the V source. Means that if we have source of 10 volt, if we need only 5 volt, so we just adjust the duty cycle up to 50%, 0.5 of 10 volt, like that. So just consequently happen that the formula solved to be like this for this buck converter circuit. Okay, so it means that the amount or the area of A should be the same as B. The above equation implies that the area of A and B must be equal. When we assume at the 5 condition just now, the ideal parts that being used, the operation happen in steady state, and the current flows on the positive mode, CCM. So this kind of output is expected. Means that the output V out equal to Vs times D, or D times Vs. Okay. Okay, as for the current point of view, for CCM in steady state, the average capacitor current should be 0. So that the average inductor current must be at the same as the average current in the load. So IL equal to I out equal to V out over R. Okay, the maximum and minimum value of inductor should be, this is minimum value, this is maximum value of the inductor. For CCM, maximum and minimum are at the positive side. But for DCM, discontinuous or at boundary, the minimum should be at 0. If in the discontinuous, a boundary at 0, if discontinuous, the I min should be below negative. Okay. So maximum inductor current can be shown here, whereby the switching frequency is equal to 1 over T, 1 over period. So for CCM, I min must be positive. So this is the formula for how you want to find or calculate your inductor value. Okay, IL min equal to 0 at boundary or discontinuous mode. So L min equal to 1 minus D times R divided by 2 times your switching frequency. So for voltage ripple, which is delta V out divided by the amount of output voltage, at this condition we consider at the capacitor to be very large, such that the output voltage will be stabilized, constant. However, in practical, the output cannot be kept constant always.